Hi, this is just a short reminder video about some acid-base reactions as we enter into the solutions unit. Definitions of acid and bases. The Arrhenius definition has everything to do with the amount of H pluses that put into the water and the number of OH minuses that are put into the water. Whereas the Bronsted-Lowry definitions are all about proton donors and protons and acceptors. And if you remember what a proton is basically just the same thing as an H plus. Okay? If you remember the hydrogen atom, you have a proton in the middle surrounded by an electron. Okay? And that's a negative charge. If we remove the electron, all you're left with is your proton. So that's why the proton right here, you're just adding that H plus. Okay, which can come off of the H2O. So you have to be able to recognize Arrhenius definitions and Bronsted-Lowry definitions. Strong acids and strong bases, they completely dissociate, and weak acids and weak bases do not completely dissociate. Common strong acids and bases, you are probably going to need to memorize these. Okay, so we've got 6 of the acids and bases: hydrochloric acid, hydrobromic, hydroiodic, nitric acid, perchloric acid, and sulfuric acid. Those ones come up quite frequently. The common strong bases, are the lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. And if you looked at a periodic table for the bases, they kind of come down to lithium, sodium, and potassium, and they come over to the alkaline earth metals, sort of like a Tetris character, and they drop down calcium, strontium, and barium. That's how they are on the table: lithium, sodium, potassium, and they cross over to calcium, strontium, and barium. All right. So it gives you just a little bit of information. But now let's take a look at the piece that is the most important for doing our calculations, and that's the neutralization. And we do that with the equation MAVA equals MBVB, where M is molarity and volume is base. Volume could be in liters or milliliters. What's most important is that you keep it consistent throughout the problem. So let's do this example problem, the first one together. What volume of a 0.100 molar hydrochloric acid solution, and hydrochloric acid, you'll need to know HCl, is needed to neutralize 25 milliliters of a 0.350 molar sodium hydroxide solution? And sodium hydroxide is the NaOH. And so if we're going to make this, we need to know what our variables will be. So the molarity of the acid is 0.100 molar HCl. The volume of the acid is what we don't know. The molarity of the base is equal to 0.350 molarity for the NaOH. And the volume of the base is equal to 25.0 milliliters of NaOH. Okay? All right. Then we're just going to solve our problem. MAVA is equal to MBVB, and we're solving for VA. We isolate that, so VA is equal to MBVB over MA, and we solve that. VA is equal to 0.350 molarity times 25.0 milliliters, all divided by 0.100 milliliters, and your volume of your acid, you plug that in with sig figs, of course, 87.5 milliliters. And of course we have to include units. So hopefully you got that answer. And then one other problem right here. If you want to pause the video and try to figure that out, do that now. And now that you've restarted the video, the answer you should get is that the molarity of the base is equal to 0.10 molar KOH. Okay? So now that this video is finished, you'll need to You'll need to watch 2 more videos and then go answer the quiz questions on Schoology. Oh, you're already there to get the videos. Thank you, and let me know if you have any questions.